Now let us solve these three problems. If you observe the first one, integral of 3x minus 2 whole to the power of 4 dx. If you observe, this is not x, so it is not in the form of x power n. So then what we need to do, it is a linear polynomial. So first by using binomial theorem we can expand it, or else here we will use a simple technique. Let us consider 3x minus 2 as some t. So instead of this, if I consider this is a single variable, then it becomes t to the power of 4. So it becomes x power n format. But there are some changes. If you write this is a t, but here we are supposed to integrate this function with respect to x. If you just replace this one with t, integral t to the power of 4, but that function is to be differentiated, we need to integrate with respect to x. So the variables are getting changed. For that, let us consider this part, 3x minus 2 equals to t, and differentiating both sides with respect to x. Then what will get? This 3 into, it's very clear, 3 equals to dt by dx, transposing 3 to this side and dx to this side. Then what will you get? Dx equals to 1 by 3 into dt. So even dx also we can change it. Now integral, in place of 3x minus 2 we can write t to the power of 4 into, in place of dx what can you write? 1 by 3 into dt, right? Now it can be written as 1 by 3 into integral t to the t power 4 dt. So if you observe that it is in the form of x power n, integral x power n dx. Here it is a t power 4, even we are, with respect to t we need to integrate. So that will get 1 by 3 into t to the power of 4 plus 1, that is 5 by 5 plus c. Now let us replace, because the function is given in terms of x, so even the result should also be in terms of x. So now let us replace t, that is 1 by 3 into this, what can I write t? 3x minus 2 whole to the power of 5 by 5 plus c. If you observe that, so the integral of, therefore the integral of 3x minus 2 whole to the power of 4 dx is, if you observe that it is same as x power n, we have solved it, 3x minus 2 whole to the power of 5 by 5 plus c. But here the coefficient of x is, here we are dividing. The same concept if we apply in differentiation, we are supposed to multiply it. In case of here we are supposed to divide. This is only when the function is a linear polynomial. We should be very careful. So let us, first one we have already discussed. Now coming to the second one. What is the second one? Second one is integral of 1 by root 5x minus 4 dx. Even let us solve this one with a previous technique, and how to solve this one directly we will discuss. So here it is not, even if you try to convert, we will write this one as integral 5x minus 4 whole to the power of minus half dx. Even if you try to this one by using binomial expansion, it is not as easy as previous one. Expansion, it contains infinitely many terms, so that expanding this one by using binomial theorem is not suggestible. So here let us apply the previous technique. What is that? Let 5x minus 4, let this is equals to t, and differentiating both sides with respect to x, then we'll get 5 into 5 equals to dt by dx. So transposing this, 5 to this side, dx to this side. So dx equals to 1 by 5 into dt. So here if you observe that the coefficient of x we are getting here. Now let us apply this concept. Integral 5x minus 4 can be written as a t to the power of minus 1 by 2 into, in place of dx what can you write? 1 by 5 into dt. So if you write that 1 by 5 outside, integral t to the power of minus 1 by 2 into dt, it is same as normal function, only what we are getting? 1 by 5, that is the coefficient of 5 we are dividing here, that is 1 by 5 into, what will get? Integral of this t to the power of minus half plus 1 by minus half plus 1 plus c. On simplifying, what will you get? 1 by 5 into, this becomes plus half, this becomes plus half, so we will get 2 into t to the power of 1 by 2 plus c, that is 1 by 5 into 2 into, what is t to the power of t value is 5x minus 4 whole to the power of 1 by 2 plus c. So even here also this part we are getting, that is the coefficient of x is dividing here. So from this we can conclude, even what is that? Integral of f of ax plus b dx. Here the same, in place of ax, here we will get integral of same function, that is 1 by a into something we will get. This is what the coefficient of a we are supposed to divide. That's the only thing. Let us solve the next one also. Third one. What is that? Integral of root of 2x plus 3 dx. Now if we apply the previous concept, what will get here? This is integral of 2x plus 3 whole to the power of 1 by 2 dx. Now we need to consider this as a single variable, so that what will get? 2x plus 3 whole to the power of 1 by 2 plus 1, that is 3 by 2 by 3 by 2 plus c. But here the coefficient of x we are supposed to divide, that is into 1 by 2. Then what will get here? This 1 by 2 into, it becomes 2 by 3 into 2x plus 3 whole to the power of 3 by 2 plus c. This is the answer. Even you can cross check by considering 2x plus 3 as a t. So this technique, that is, let 2x plus 3 equals to t, and differentiating both sides, 2 equals to dt by dx, and simplifying, transposing this 2 to the side, dx equals to 1 by 2 into dt. Now applying this one, what will you get here? This becomes integral root t into 1 by 2 dt, that is 1 by 2 into integral of root t. What will you get here? Root t dt, that is 1 by 2 into, here 2 by 3 into t to the power of 3 by 2 plus c will get. Now replacing t value, 1 by 2 into 2 by 3 into t value, what is that? 2x plus 3 whole to the power of 3 by 2 plus c. This technique what we call as a substitution technique. In place of one function we are substituting some other variable. This technique is very important in further classes. So as of now we can go through this process. Whenever a linear function is involved here, function involving linear polynomials are involved, we can go ahead with this process.